Hello, everyone. You are welcome to this session. And in this session of functions, okay, we'll be looking at the solution to the assignment that was given in lesson 2 of relative math functions. Okay, so we have a simple task. We are going to look at the solution, and indirectly, it's also a marking scheme. Okay, so which will help you, okay, do the needful. So we had these two as the assignments. Quickly, let's go and look at the solution. I'll walk you through the solution as well as what the marks assign to the steps there. So as usual, anytime you read question, you see question, you read question, check whether you have salient parts to underline. And here, you don't have any salient parts. After that, the first thing that you write is solution. The assignment here is not necessary. I just want you to know that there's a solution to the assignment. That's all. Okay, so you just write solution. Okay, then questions are numbered because we want you to number your solution. So once the questions are numbered, your solution equally must be numbered. So you have to write the one there. Then you go and extract, okay, the two functions that will help you find h of g of x. So giving g of x is equal to this, okay, h of x is equal to, thankfully, the two functions came in the relation form. So you extract them, okay, in that same or exact form. And what do? You come and write whatever you are supposed to use, okay, these two functions to find. So h of g of x, that's what you are supposed to find. So your first step, you know that h of g of x, its basic meaning is h, you feed it with g of x. Okay, so that will mean that wherever I see x in h of x, I put g of x there. But I know g of x, so it means this will give me h into g of x. What is g of x? G of x is 1 over s plus 2. So 1 over s plus 2 will take the place of position of what? The g of x. So at this point, wherever you see x, h of x, it becomes, okay, 1 over s plus 2. So if you look at h of x, okay, h of x is giving you a fraction. In the numerator, you have x, and the denominator also contains x. So if you are going to substitute your new input, which is 1 over s plus 2, then it means, okay, this will read my x, which is now 1 over s plus 2. So that's what will occupy my numerator. The whole of that over 3 minus x, okay, and it will be 3 minus x, which, okay, like I said, okay, ordinarily you were supposed to put this in brackets because you are substituting, and also this in brackets. But I have shown a little bit of maturity in the presentation. I've told you, if you are not that mature, better to play it safe. So anytime you are substituting, okay, at this point, what you are confronted with is what? Order of operation, because you can see a lot of operations over there. Now, remember in our previous meeting, I told you that anytime you have an expression, okay, where you have more than one division bar, okay, so this division bar, you have one is here, another division bar, another, so here you have even 3, okay, so you cannot end here. Your final fraction must always involve only one division bar, only one, not more than one. So it means we have to remove some of the division bars, basically. And I told you that this division bar here at a point, change to division symbol. At the point that you can change it to division symbol, that's the point that you know your numerator and the denominator, both of them will be expressed, okay, in single fraction form. So if you look at this, you can see that the numerator is already a single fraction. Do you agree? Hello,
Yes,
do you
please.
agree? Okay. Is the denominator a single fraction?
Yes, please.
The denominator, is it a single fraction? No, it is not. Okay, because you can see you have two terms. This is over 1. Okay, every single fraction will be a term. So this is a single fraction, it's a term. However, here you have how many terms? This and this, where this is a fraction. So you have two terms, so this cannot be a single fraction. So it means the numerator will be kept intact and the denominator, okay, must be expressed as a single fraction. So in my next step, okay, I will keep my numerator intact. divided by, then I know I can change this one to divided by because I know that my next step, I can change this to a single fraction. So that's the more reason why I change the division bar here to the division symbol. Then I come and take the LCM, okay, writing this as what? As a single fraction. I know some of you who do this, okay, will change, we'll still keep this, so we'll write 1 over, okay, s plus 2, okay, then divided by, okay, 3 minus 1 over s plus 2. Okay, so you can do this, okay, you can change the bar, okay, here to the symbol. But if you do it at this point, where after or before and after the division sign or symbol, okay, what you have there is not a single fraction, then it means the one that will not be a single fraction or it's not a single fraction must be put in brackets. Other than that, the meaning changes. Because if you fail to bring the bracket, it will mean this is being divided by only the 3. Do you agree? Meanwhile, what you have here, this is being divided by the whole of this. So that's the more reason why I usually encourage students, I advise students to desist from, okay, changing the division bar to the division symbol where what you have before and after the symbol, the division symbol, not a single fraction. And if you do this, it's allowed, only that you know, order of operation. Whenever you are dealing with BODMAS, what are you doing? Are you not removing operations? We use BODMAS to remove operations, that's not it.
Yes, yes.
Okay, yes. But you can see that what have you done here? You've introduced brackets. Is brackets an operation? Is bracket an operation? Or are brackets operations?
Yes, please.
It is. So you can see that instead of removing operations, you are rather introducing operations. Okay, so I will not encourage you to go this route. Okay, so here you should know that, okay, my next step equal to, this is already a single fraction. Okay, my next step, I'll work on this one and write this as a single fraction. Some of you can do this, okay, but again, I will tell you why, okay, I will advise you not to do so. Some of you can do this and come and take the LCM and compute this one just below it. But you can see that if you do that, you are going to use 2 lines here, 2 lines here. So indirectly, you are using how many lines? 4 lines. So at the point where you know the denominator will be expressed as what? A single fraction, you can change the bar straight away to this and come and take the LCM rather than writing this one below here. I don't know whether my point is well made. Am I clear enough?
Please come again.
Okay, I said some of you can do this. Okay, you know, you can write when okay, assuming maybe I give you in terms of numbers, 1 plus maybe 1 over 3, all over maybe 6 minus 1 on 2. Okay, you know, usually what you do is you come and take the LCM, okay, then come and take the LCM of the denominator too. You get a point? So it means I am going to get something over something here, all over something over something. You get it?
Yes, please.
And it's at that point that you know that the numerator, denominator are single fractions. So that's the next step for you would be whatever fraction that you have in the numerator, okay, whatever fraction. Now you change the division bar to the division symbol over whatever fraction that you have there. And I am saying that you can, okay, change the division bar, division symbol at this point where you realize that, okay, going to have before the division symbol and after the division symbol a single fraction. So that you don't write it this way to occupy more, okay, space or more lines. I guess my point is well made now.
Yes, please.
Okay, so that's why I wrote it side by side. Okay, because this is a single fraction. This one too, divided by, once I write divided by, then it means I know what will come after be the single fraction of this. So I come and take the single fraction. So taking the single fraction, you know this is over 1. Okay, only that we usually don't write it. So your LCM will be s plus 2. So you ask yourself, 1 will go into s plus 2 how many times? It will be s plus 2 times 3. So that's how come you have 3 into s plus 2. Then you keep your sign minus. And you come and ask yourself, x plus 2 will go into x plus 2 how many times? And it will be 1 times 1. So that will give you the one that you have here. So at this point, this is kept intact. It's just that you have to work on. This fraction is completely, okay, stable the way we want it to be. Is this one that is quite sick? We have to work on it. So it is divided by, then I come and remove brackets, which gives me my numerator here. The denominator will be intact. Okay, then again, I simplify. Okay, then after that, what do? I change the division bar to the division symbol to the multiplication symbol and invert. And that will give me what I have here. And I draw my conclusion. Is my point well made, my professors?
Yes, please.
Okay, so now these are the marks allocation, how we mark. You can see B and M and what have you. Okay, usually we give B marks for formulas, for diagram, for statement of facts. Okay, so here you extracted. This is a statement of fact you extracted. So anytime, so that is B half. So the extraction, you shouldn't lose the marks for that. Okay, these are low-hanging marks. You shouldn't lose it. Okay, then you come to h of j of x. You know, this one is also a fact. Okay, it's just you know that this means h, you feed it with what? J of x. So that's how come it is attracting a B mark. So B half. Okay, however, what we are doing here is method. Okay, so this one will be M1. But take notes. Sorry, take notes. Someone can move, if you are smart, you can move from here to here straight away. Okay, so if you move from here to here, it will not be costly. Okay, we will combine these 2 marks and give you the 4 marks. So you would rather get, okay, your B half here and your M half. Sorry, M1. So you get your 1.5 marks here. I don't know whether my point is well made. Because you can see that what is written up here is embedded in this. Do you agree? So this is also in this. So we'll give you the 2 marks there. That is the mark for this one and the marks for this one. Then after that, this is also a method mark. Okay, this equally a method mark, M1. So check and, okay, put wherever you see that, put M1 there, M1. Okay, this one is also a method mark. Okay, so M1. Okay, then someone can move from here to here straight away, meaning you know you will change this one to multiplication and invert. So once you change this one to multiplication and invert, the numerator, which will become the denominator, to write a simplified form. So you do that. So someone can move from here to here straight away. So that's the more reason why it's not attracting any marks. Okay, so take notes. All right, then, okay, so this one, whether you like it or not, you are supposed to write it. So you write it and you get your M1. Then when you know what to do, this cancels that. Okay, so it will be 1 over 3x. Okay, so before it will be 1 times 1, which will give your numerator 1. And this has cancelled, so it will be 1 times this, which will give us what you have here. So your A1. However, our conclusion must come. Someone can conclude here. So in that case, the person will get, okay, this mark and this mark put together. Take note. Okay, so that will give you your A3. However, before you get your final answer mark, which is the conclusion mark, okay, take notes. Okay, this condition must be attached. Remember, I told you, anytime you find any function and the denominator, okay, contains a variable, it means your x must be, or your variable must be constrained. So in this case, how did we get, okay, our x not equal to minus 1 whole number 2 on 3, because we said we have to do 3x, the denominator, okay, should not be equal to 0. So you get 3x should not be equal to -5. Then you divide by 3. I've told you, once there's a rough work, okay, it's not necessary to write it again and divide. Rough work shouldn't be that detailed. So you just come in, right? Okay, x will be equal to -5 on 3, so not equal to, but you know. So someone can conclude with this, no issues, because this is not your, so only that, remember, for consistency's sake, anytime you have an improper fraction, change it to corresponding Maize numbers. Okay, so it means if you wrote -5 on 3, okay, here, okay, I will still give you the marks. So now you know how to mark. So the total mark, okay, if you check, the total will be 9 because it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total marks, 1 mark. Let me finish. I will call you. Will be 9 marks. Okay. However, I always add bonus marks, so 1 bonus. And this is how I am going to award the bonus. If you go through all that and you get 8, your total marks, when you sum, you get 8 or 9. Then you get the bonus of 1. So it means if you had 8, you add 1 to 8, and that will give you 9. If you had 9, everything right, then you add what? 1 to 8. So it means you get 10 out of 10. You get the point. So it means in total, it's supposed to be 10. In total. Plus the 1 bonus is supposed to be 10. So mark yourself and grade yourself as well. So write your total marks there. So if let's say you had 8, write 8 over whatever, 10, then circle it, or you can choose not to circle it. On top or below, please take note, on top or below. You capture it and send it to me. Take note. Are you there? Hey, I saw, Paulette Paris, let's go.
Sir, please, you see, you got your final answer 1 over 3x plus 5. Please, there is a mark for that one. So does it mean that if you don't conclude and you just come to do therefore, you will not get the mark over there?
No, if you don't conclude, which one? Therefore is the conclusion.
No, I mean the 1 over 3x plus 5, you attach an A1 mark to it.
This one?
No, before that.
This one, yes, I said, remember I said, if you move from here to your conclusion straight away, then you add these 2 marks. So you get 3 here, you put 3 here. You get it? Because
yes,
someone can draw the conclusion there, like I said.
Okay, thank you.
And please these are the penalties, especially the advice that I've been giving you and some of you are not taking. If you left spaces between your steps, minus half. For now, I'm going to be lenient. If you left spaces between your steps, minus half. Take note. If you started introducing your steps with implication, ordinarily I'm supposed to give you 0, M0, what have you, but I am going to give you, so change it to equal to, if you have implication, any implication sign there, change it to equal to n minus 1. Is that okay? Are you listening? The penalties.
Yes, please.
Okay, please just be honest. We are learning. And again, remember I told you that, you cannot write equal to before this. Because this one, what is equal to this? So if you wrote equal to before the h of j of x, what was given? That one too minus half. We are learning. It's some of these things that will make you, learn from your mistakes. Because I know you cherish marks. So when you are losing what you cherish, next time, I know you will do the right thing. All correct? Are we all fine now? Okay, Prof. Piero, Peter. Please unmute and talk. Oh, Piero, we can't hear you.
What if you don't add the constraint? Will you?
No, so if you don't take notes, if you don't add the constraint, you will lose. If for you to get the final answer mark, please listen and listen carefully. For you to get the final answer mark, what you have there, I think I've mentioned this before. What you have here must be exactly the same as what is here. But maybe today I'm going to be a little lenient. So if you don't attach the constraints, it will be minus 1. So you get A1. But ordinarily it would have been A0. Next time I will not. Is that clear? Okay, all right. Okay, so Prof. Ike.
What if you add the constraint, but you forgot to leave it in this one? You left it
in the Mace form. So I said it. I said if you leave it in this form, you get the 8. Only that For consistency's sake, anytime, because this is conclusion, change it to mixed numbers. Exactly. Next time. But today I'm going to be lenient. Okay. Lillian, Prof. Lillian.
Please, at the fifth step,
1, 2, 3, 4, 5.
if you after the fifth step, if you skip the sixth step and you cancel right away and then you conclude.
No, you cancel, you skip this one.
Yes.
And you come to which step? This step cannot be skipped.
Yes, that step.
This step is there.
Yes,
Is this
please.
step there? But this is not there.
Yes, please.
I said it. I said you can always skip this. That's the more reason why mark is not there. You get
Okay.
it? So you
Yes.
can skip that. Okay,
Thank
so
you.
but this one is not. So I think what we are doing is useful, right?
Yes, please.
Yes, please.
Very good. All right. So please, okay, attach that seriousness to it. And again, those of you, if you wrote this, please take note. If you change the division bar here, the division symbol, without putting this in brackets straight away to M0, as for this one there, as for that one, no mercy. Okay, quickly, let me see. If you immediately you write this without the brackets, okay, it will be this step here becomes M0. I'm talking about this step, but that's where you change. That will become M0. Okay, and once you have M0, automatically everything is 0. So M0 is 0. Take note. When a step is wrong, marking becomes very easy, especially if that step takes a method mark. To be M0 is 0. Even if you come and do the right, you come and get the answer right, you had the answer right, okay, magically, okay, not mathematically. Because if you write this, it is only this that must be divided by this. So if you proceed and you come and divide the whole of this one by this, you are wrong. What you wrote without the brackets. So please take note. Am I clear, my professors? Okay, all right. So if that's the case, can we move on to question 2? Okay, so
Yes.
we are moving on to the second question. Okay, so the second question 2, so solution question 2. Okay, you extract. Okay, the functions didn't come in the relation form. It came in the mapping form. So you know you extract in the relation form. So those of you who didn't do that, penalty will come. Okay, then h of f of what? 1/3. So we know this means, okay, what we have here. Take note. So it will be h, you feed it with what? F of what? 1/3. And this also more or less a formula, okay, mark, a fact. Okay, so you know, wherever you see x in f of x, okay, it will be what? 1/3. And where is your f of x? This, so it means it will be in brackets 6 minus 5 into s, by your x is 1/3. The whole of, and you can use your calculator. Okay, no, but before you use, please, anytime you have brackets, remove bracket before you use your calculator. Take notes. So here, there is a bracket here. So I'm going to say, it means before I use my calculator, the expression or the quantity that I want to find, it shouldn't involve what? Brackets. Take notes. So I remove the bracket and that gives me this. So it means at this point, I can use my calculator to find 6 minus 5/3. And I write this one. Please take notes. All right. Okay. So at this point, this is what we are supposed to get. Okay, so now we have h of 13 on what? On 3. No, you are not concluding with this. So you keep the 13 on as what? The form that you have there, that is the improper. Don't change it. Because if you change it to mixed numbers, you have to change it back to the improper when you are substituting. So just work with it. You are not concluding. Okay, it's only a means to an end. So h of 13 on 3 means wherever you see s in h of x, it is 13 on 3. And where is your h of x is this. So this x becomes 13 on 3. This x also becomes 13 on 3. So that's what I did. So it will be 2 into x, which is now 13 on 3 plus 1, all over 3 minus what? Your 13 on 3, which is your x. So you put there. And at this point, you can't use your calculator to compute the numerator straight out because you can see brackets there. So remove the brackets. Before you move the bracket, check whether you can reduce. We can't reduce. So if you remove the brackets here, you get 26 on what? On 3. Remember, the 2 will multiply only the numerator, not the denominator. So those of you who did that. Okay, you didn't see me marking, but I went through all that you sent to me for me to know exactly what to say today. Okay, so then plus 1. You come to the denominator too, so to give you 3 minus, okay, you remove the brackets. And even in the denominator, okay, you could have ignored the bracket because just a 10. Okay, and I said just for safety reasons, that's the more reason why it is. And that gives you what you have. So at this point, I can move from here just straight away because I can use my calculator to find this value, which will give me a single fraction. So I write it. Because it's a single fraction, and I know that I'm going to use my calculator to get this, which will also give me a single fraction. At that point, I can change this division by here to the division sum. So your calculator, this will give you -4. And after that, you know, okay, you write this, then you reciprocate. Change it to multiplication, you reciprocate. Then you come and what? Cancel. Okay, you reduce. Don't multiply before you reduce. Always reduce before you multiply. So this can cancel that. So I'll get 29 times -1, which will give me -29. And this is 1. 1 times 4 will give me 4. However, I can't conclude with this. Even with this one, when you get here, okay, you can use your calculator to get this straight away. Okay, and no issues. Only that the one who can do it mentally will get the answer before you even feed your calculator. Okay, so at this point, you come and draw your conclusion, and you know you avoid concluding with this type of fraction unless otherwise stated. So you change it to the corresponding base numbers. So the marks are located, as you can see, when you extract b half. Okay, when you use the fact or the formula, okay, what do you call it? B half, method mark. Okay, method mark M1, 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 M1. Okay, so then M1, A1, and A1. Take notes. So if you fail to conclude, or when you conclude with the improper fraction that you have here, it will still be A0. You get the point? So take note, you cannot conclude with this. Okay. And someone would have concluded straight away at this point. So if you concluded by, okay, not going through this straight away, because someone can do this mentally. Okay, then you put these 2 marks together and you give yourself A2, provided you change this one to minus, okay, I mean the corresponding base numbers. Please, is the explanation okay? Before the marks, is the explanation okay?
Yes, please.
Okay, very good. So this will be it in terms of the solution to assignment. Any questions before I move on? And the penalties. Okay, if you extract the function in the mapping form, you get it to be -half. Take note. So it means you indirectly your b half is. If you start this one with equal to -half, take notes. If you use implication here anywhere, okay, it will be -1. If you leave spaces between your steps, it will be what? -half. Take note. So now let's look at the total for this one as well. Okay, so the total, okay, let me, okay, address the total then. So the total here, I think this one will also be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total is 9 by 2 plus, okay, a bonus of 1. Okay, so making it what? 10. And for you to get the bonus of 1, the 1 mark that you have again, you should get either 8 or 9. Take note. So if you had 8, then it will be plus a bonus of 1, which will give you 9 over 10. If you had 10 plus the bonus of what? 1, which will give you 9, sorry, 10 on 10 if you had 9. However, if you had 7, no bonus. So it will still be 7 over 10. Is that clear? Even if you had 7.5, it's still not 8. It will be 7.5 over what? Over 10. Or 7.5 over 10. Okay, so Prof. Paulette Paris.
So please, what if you skip the first step?
Which first step? This one.
Yes, please.
And you came to this straight away.
Yes, please.
Okay, so just like I said previously, you can say that that question is answered. You put these two together. So you write, okay, when we are marking, you skip this, which you can. Okay, we write this one here, we write, what do you call it? B half, okay, M1, so that you get your total as there. So the B1 half will be given as well, like that. Is that clear?
Yes, please. Thank you.
You are welcome. Any further questions? Okay, so we thank God we are all fine. And once again, thank you very much for a successful lesson. Okay, God bless us all.